Good morning, students. Can you hear me? Can you see the screen?
Yes, sir.
All right, good. I find that the recording from the other day been a little bit low, and I don't know. I don't know why. I really don't know why that is the case, but let's just proceed. So a lot of persons missing. Part of the session is being recorded, so let's hope everybody will go watch the video afterwards. All right. So we're on the functions topic, as you know. We will continue with functions tomorrow, and this is a class activity that we did this week. Just want to go through this class activity one more time, and then we will do a few questions from past papers that I sent yesterday, so that we can put into practice in a real way what we're learning in class. Always say it: if you can do it in the class, then you can do it in the exam. If you see it on exam paper, you can do it, then when it's your time to do it in an exam, you will be able to do it. Right? And you should have the confidence to be able to do it. And that's why we have to always present the past paper questions, so we can see exactly how the questions are written, and build our confidence in being able to do those questions. All right, bam, bam, bam. So this was a classwork, guys. A functions question presented us with two functions. Right? Those are nonlinear functions. This one is called a rational function. And this is what we might want to call as a power function, because it can be written like this one can be written like x plus 3 to the power half. So I might want to just call it like a power function. But this one is what we call a rational function. So these are most of the questions that you see on past papers will be like simple linear functions like 2x plus 4, for example. F of x equals 2x plus 4. So if you can deal with functions looking like these, so a little bit more complex looking, then we can deal with the simple ones. And as I was saying in the class the other day, anything you do with the simple functions, you're basically doing the same thing with the complex looking functions. It's just that you might have more operations to simplify and rearrange and so on. But the basic concept and the basic approach remains the same. All right? So as I said, this is the f function, that's a g function. And the first question here wants us to find g of 6. So g of 6 is formed by substituting 6 in the g function over here. So wherever the x is over there, we're going to put 6 in it to find g of 6. So let's go. So g of 6 for part A. What's happening over here? Pen is not writing on the right. Oh, right. So g of 6 is 6 in this g function. So it becomes the square root where this x is, I'm putting 6 there, plus this 3. The 6 and 3 here is 9. So we're doing the square root of 9. Square root of 9 is 3. So g of 6 is equal to 3 in the first part. The second part, that's part A. Part B is now asking us for f of g of 6. F of g of 6. Now the thing to remember about a composite function like this is that you have to do this part first. You do g of 6 first. But guess what? In this question, we already know what g of 6 is from here. G of 6 is actually equal to 3. So it means that we are able to replace this g of 6 with 3. So in essence, we are therefore finding f of 3. F of 3. Because, as I said, the g of 6 is this 3. And so we're finding f of 3. Simple as that. A lot of persons went about working out the g of 6 again. You don't need to work out the g of 6 again. You have it here already. So how do you get f of 3? F of 3 over here is now found by putting 3 in the f function, wherever the x is. That's how we find f of 3. All right, and then if we do that, we're going to end up with f of 3 being equal to 2 times 3 up here on the function. 2 times 3, and then minus 7 over here. Minus 7, and you're dividing that by the 3 right here where the x is, 3 plus 1 over here, plus 1, plus 1. And that is it. Everybody can understand that? Everybody good with that?
Yes, sir.
Good. And then what it is that this is 6 minus 7. 6 minus 7 is negative 1 divided by 3 plus 1. 3 plus 1 is 4. And so that is the answer right there. Negative 1 over 4. Alright? So that is it. That's the easy way to do it. Then we'll come to part C, which has 3 parts. 3 parts. Alright? So let's go. So the first part wants f to the minus 1 of negative 1. So what is the approach? Here's how we've been doing in class so far. The approach would be to find the f of x first, f to the minus 1 of x first, and then put the negative 1 in it. Alright? So let's set it up. We have f of x equals 2x minus 7 divided by x plus 3. And the question is asking us for f to the minus 1 of negative 1. To find f to the minus 1 of negative 1, what we're going to do, we're going to find the inverse first, f to the minus 1 of x first. And after we find f to the minus 1 of x, then we will find f to the minus 1 of the negative 1 by putting the negative 1 in this f to the minus 1 function. So how do we get the f to the minus 1 function? We do the same way we would with a simple function. Let's work it out in purple. So this is f of x equals this. Now some teachers will go about calling this y. I'm just going to call it f. By calling it f, I'm relating it back to the original function f. So I'm just going to call it f equals 2x minus 7 divided by x plus 3. So like I've just left out this of x expression, left it off. Don't need it. And then when you form the inverse function, it's an interchange of the domain and the range on graph or theoretically. And so we do the same thing with the mathematics. So on this function, this represents range right now. And then this and this, they each represent domain. And we're interchanging those to form the composite function. Alright? We're interchanging those. So how do we interchange them? Simple. When we form the inverse function, we're forming the inverse function like we're inversing this function. What happens is that this f, which represents the range on the function, becomes the domain x on the inverse, equals the two x's here, each of them, they represent domain on this function. They're going to become range on the inverse. Range on the inverse of a function f is written f to the minus 1. So it's going to become 2 times f to the minus 1. That's what this becomes, because it becomes a range on the inverse minus back this 7 divided by this x also becomes range on the inverse, which is f to the minus 1 plus 3. And so this is a function and this is the inverse. It's just that on the inverse function we need to make the f to the minus 1 the subject. And there have 2 of them in the expression, 2 of them in the whole equation. And we really want to only get one f to the minus 1 as a subject. So we don't want them to be dividing one another in a sense. We want to expand this out into separate terms, so that we can group everything with f to the minus 1 on one side of the equation and then everything else on the other side of the equation. But the first thing is to separate it out into separate terms. To do that, you basically take this denominator and you multiply it up across here by the x. That's the first step. Because you can always cross multiply, because this x is almost the same as x over 1, you know. And you can always cross multiply values on either side of an equation where both sides is a fraction. You can cross multiply and cross divide like that. You're not changing any sign. You cross multiply and cross divide it. Right? That's simple operation that you should know. What is happening in the background really is that you're multiplying both sides by this denominator. Multiplying the right side by f to the minus 1 plus 3. And multiplying this side also by the same f to the minus 1 plus 3. In a sense, that's what you do. and then this one cancels that one. So the end result looks as if we multiply this denominator across here. And that's a shortcut. So we work with the shortcut. We understand what's happening behind the scenes, but it is okay to work with the shortcut. And the shortcut is simply say, this over here is dividing, we bring it over here and multiply with it. Bring it up. Shortcut. Alright, we work in the shortcut because shortcut saves time. It allows us to do less writing. Right? And additionally, CSEC don't give a lot of space on the exam paper for you to be writing too many things unnecessarily. So we have to learn the shortcut while we understand what is happening in the background. We understand we write the shortcut. Right? So you're not going to lose marks for just taking this denominator and multiply it across here. Remember also now, if you're multiplying this whole denominator by this x, you have to multiply each of these values by the x. So it's x times the f to the minus 1 and x times the 3. Alright? So I'm explaining as I go. So ready now. We're doing it now. So it's going to be x times f to the minus 1 first. That gives you x times f to the minus 1. And then x times this positive 3 gives you plus 3x. Plus 3x. And then this numerator remains on the right side, which is 2 times f to the minus 1 minus 7. That's what we have so far. Alright? Now remember now, we want to get f to the minus 1 alone on one side. So we really need to get this term over onto the left side, and we need to get this 3x over onto the right side. That's the transposition we want to make. And we can do two of them in one step, in one line. We don't have to do two lines to show this. Alright? So those are the two things that we're moving. So I'm going to underline them for now. We're moving this, and we're moving that. This going so, this coming so. Alright? So this stays where it is. That don't change. It stays as x times f to the minus 1. Then this now comes on this side of the equation. It becomes a negative because over here it's positive, you know. So it becomes a negative 2 times f to the minus 1. And then this now is going to go over. Right? So I'm going to write by the equal sign now. This is negative 7. It stays negative 7 because it's not moving. Don't put 7. It's a negative 7. So it stays as a negative 7. And then this 3x, when it comes over, it becomes a negative. Because right now it's positive, it comes over and becomes a negative 3x. Again, we have done some shortcut. Because theoretically, let me move this down. Let me move this down onto the next page. Because theoretically, what we just did, theoretically, is to first subtract this from both sides. So like we subtract 2 times f to the minus 1 from this side and subtract it on this side as well. Subtract it on both sides of the equation. So this one wipe out this one, and then this remains on the left side. That's how it ends up there, right? But shortcut is to say you bring it over on the left side and subtract it. And then the same thing up with the 3x. The 3x over here is like we don't want it on here, so we'll do a minus 3x on the right side, on the left side, sorry. So we'll do a minus 3x on the right side as well of the equation. But this one will wipe out this one, and so we're left with this one over here on the right side. But shortcut is to say we take this and bring it over here and change the sign to minus. And we work in the shortcut as for the same reason that I just explained. Alright, so that is what happened. So this is where we're at now. This is where we're at. Oh, sorry. This is where we're at now. This. Alright, remember now, we're trying to make f to the minus 1 the subject. So what we're going to do now, we're going to take the f to the minus 1 that is in these two terms and factorize it out of those two terms. So you factorize the f to the minus 1 out of these two terms. Out of this, you're left with an x. Out of this, you're left with a negative 2. And the right side remains the same. Minus 7 minus 3x. Minus 7 minus 3x. Let me just check something. Just to make a mistake. You couldn't tell me. I have 3 right here and it's supposed to be a 1. Where did I get a 3 from? So let me just make that correction now. So it's supposed to be a 1. And so this is supposed to be a 1. Let's change all of them now. The process is the same. Just I wrote on the wrong thing. And this is supposed to be a 1. And then this now is supposed to be a 1x. X times 1 is supposed to be a 1x. So that's x. I'm going to put that 1x there. And then it comes over here and it becomes a 1x as well, a minus 1x. So it's supposed to be a 1 as well. I don't need a 1, but I'm putting it there still. And this also remains a 1. It's supposed to be a 1. So the process that I was just explaining is the same, but just that I made a mistake and I wrote down 3 instead of a 1. Alright, so that's where we're at. And then now, what we need to do next now is get rid of this. I want to leave f to the minus 1 as subject. Shortcut is to take this and divide it under this side. Theoretically, what we are doing, we're dividing both sides by that x minus 2. So divide this side by x minus 2 and divide this side by x minus 2. So this cancels this. And we're left with it under here. But shortcut, instead of dividing both sides by x minus 2, that's what happens theoretically. Shortcut is take this and just divide it under this side. And that's how we have to understand these things. And so we're left with the f to the minus 1 here being now equal to this expression, negative 7 minus 1x, or just minus x, divided by x minus 2. And we're done, because we know f to the minus 1 as a subject. What that we're done, we can put back in of x here. We have found f to the minus 1 of x now. And so remember, what we really wanted was f to the minus 1 of negative 1. And so to finish this job now, we just need to put in the negative 1 in this. So we can say, therefore, f to the minus 1 of negative 1 means I'll put the minus 1 there, I have to put it here and there as well. Negative 1. And because it's negative, you have to be careful. Always be careful with the negatives. So this becomes back as negative 7 minus 1, and this x is negative 1 divided by this x is negative 1 minus back this 2. And I will simplify this. This becomes negative 7. This becomes a positive 1. Because minus times minus gives you a plus. Negative 7 plus 1. This is negative 1 and negative 2 gives a negative 3. Then the whole numerator works out to be negative 6 divided by negative 3. Negatives cancel. 6 divided by 3 is 2. So this final result is 2. And that's a lot of persons got it right in the class. That is it. But good so far. I've been here talking. But okay?
Yes, sir.
Yes, sir.
Alright, good. So the next thing we were to find was this g to the minus 1 of 1. So we'll find the inverse of this function now. Let's put that on a new page. So again, we want g to the minus 1 of 1. What is the approach? The approach we're using now is to find g to the minus 1 of x first. Then we can put the 1 in it and find g to the minus 1 of the 1. Alright? So how do we find g to the minus 1 of x? Starting with the g, this function, I'm going to leave off the of x from it. So I'm just going to write g equals the square root of x plus 3 to begin with. So instead of calling it y, it's a shorten to give the function but the same letter that it had, so we don't mix them up. And we'll do the next class tomorrow and Monday. You'll understand why, because we're going to be dealing with composite functions, inverse of a composite function, where we are using the two inverses. So I don't like to call the two of them y, because I've seen cases in the past when people call both of them y, they end up mix them up. They mix up the g1 with the f1 and vice versa. So by calling it the same letter as the original function, you tend not to mix them up. So this way you won't mix them up. So I'm calling it g instead of y. Alright, and we're going to inverse this now. We're going to inverse it. Inverse it. And this is the same concept. This on the function represents range. It becomes domain on the inverse function. This x on the function represents domain. It becomes range on the inverse of g. Range on the inverse of g is written g to the minus 1. So this becomes g to the minus 1, range on the inverse function. And put back this plus 3 beside it. So this is now the inverse function. We just need to now make this a subject. So to make that the subject, we need to transpose everything away from it. The first thing is that it is under the square root sign. The inverse of square root is square. So if I square both sides, this square will eliminate the square root sign in a sense. Wipe it out. Alright? That's why we square both sides. I'm going to leave that in red this time. Alright? So I've squared both sides in red from the original that I had in blue. When I square both sides, this side stays x squared. Equal. The squared sign is gone from this, but cancel out with this square. Cancel with the square, and then we'll get g to the minus 1 plus 3. I'm trying to make this a subject. So easy again. Take this 3, bring it over here, and subtract it. Or it's the same as saying you subtract 3 from both sides, and this one gone. Right? But shortcut is bring it over there and subtract it. So in the end, you're going to get x squared minus 3 equals g to the minus 1. So g to the minus 1 is equal to this. And because we're done now, we can put in back off x that we left off of the top. So this is g to the minus 1 of x. But it is g to the minus 1 of 1 we want. So we're going to put 1 in there now. So we can say down here. Therefore, g to the minus 1 of 1, this thing, we're going to put 1 inside here to get the final answer. So it's going to become 1 squared minus 2, minus 3, sorry. The 1 squared here is 1. So this is basically like 1 minus 3. 1 minus 3 is a negative 2. And so that is the answer for that. Negative 2. Nice and easy. Alright? Then now they're asking us to work out this composite function, g of f of x. So I'm going to write the two functions so we can construct or show how the construction will go. So the f function is 2x minus 7 over x plus 1. I can leave off x, I don't need to write it. It's not absolutely necessary. And the g function is the square root of x plus 3. And we are doing g of f of x. G of f of x means that you're putting the f function into the g function. Remember, it means f followed by g. But to form the composite function, you substitute the f1 into the g1, the inner one into the outer one at all times. It means that we're taking all of the f. This is all of what the f is. And you're substituting that in the g function wherever x is. So you're going to take this and going to bring it in the g function and put it right there where the x is. That's how we're going to construct this composite function. Quick and fast, nice and easy. Alright? So we're making up that construct. So putting back the square root sign first. Everything's going to end up on the square sign. I'm going to draw it big and tall. With the x is, I'm going to write the entire f function. 2x minus 7 over x plus 1. That's where the x is, right here. And there's a plus 3 beside it. So plus 3 beside it. And that is it. I don't need to put on these two brackets. I can leave them off. I can leave them there, or I can leave them off like that. Alright, but maybe you want to put them so it shows. Leave them off, put them, doesn't matter. But that is the end result right there. That's a composite function. Now let's say that I want it the other way, just for practice. So I'm going to copy these down. And say, let's say I want it the other way. So this is the answer, This is the answer right now. This is the answer for this question. That's the final answer. But let's say they wanted this. Let's say they wanted the other way around. F of g of x. Let's say that's what they wanted instead. I want to paste back these up here and take off the red arrows now. So if this is what they wanted, this one, then this would mean that they're putting now the g into the f, the inner one into the outer one. How do you do that? You have to take all of the g. This is what all of the g is. I have to substitute it into the f here and here, wherever x is. So this would have to go here, and also would have to go there. That's how we make that substitution to form the composite function. I'm shift this down a bit. If it was that way around. Alright, so we're gonna put the square thing there, it's gonna put back the 2, then put the square root of x plus 3, that's where the x was, minus this 7. Divide all of that. This is x is taking the place. G of x is taking that place. So you're gonna put again the square root of x plus 3, and then you're adding 1 under here. Plus 1. That is what it would be if you're finding f of g of x. But good with that? But okay?
Yes, sir.
Alright. Then now this question here, question 2 now is testing our knowledge of relationship between a function and its inverse. And I want us to do that using a graphical test. Alright? So it's something that we have to know. Alright, so let me zoom this up. So give us this function graph, right? And essentially they want us to draw the inverse on it, right? See here, we draw the sketch and show the f to the minus 1 on it. Where on this graph, the function f is this one. Now note that the function f passes through 0, 0 and also passes through 3, 3. This point is 3, 3. And this point is 0, 0. A function and its inverse must pass through the points where the coordinates are the same. A function and its inverse will always pass through a point like AA. Why? Because if you switch around AA, you get back AA. If a function passes through a point 2, 3, f, then the inverse f to the minus 1 will pass through the point 3, 2. With the coordinates switched around. What is that? You can also do this times. Alright? Is it up against this? Or against this? Yeah, times. Alright. Alright, times. That's about that, guys. Alright? So graphically, the x and y values switch around on a function and its inverse. Now, when we do the topic of transformation, we don't do it yet. That is one of the things that we're going to learn in transformation. That the transformation that reverses the coordinates of a point is a reflection in the line y equals x. Alright? So, that is the relationship between a function and its inverse. Because the x and y values switch around. The x and y values represent domain and range. The domain and range switch around between a function and its inverse. And so, graphically, it's a relation. That's a relationship between them. A reflection in the line y equals x. So if you're going to draw a graph of a function and its inverse, you want to include the line y equals x on that graph. And particularly, it reveals itself more glaringly when the x scale and the y-axis scale is equal. When they have equal scales. Because then what will happen is that the line y equals x will pass right down the middle of the graph, right down in between them. At 45 degrees and 45 degrees. And it becomes more clear when the y equals x, the line y equals x is right down the middle of the graph. You can see the reflection better. Right? And so this one is friendly to show that. So what I'm going to do, I'm going to sketch the line y equals x in red. That's my mirror line that I'm reflecting the function in. So it must pass through 0, 0, must pass through 3, 3. Line is y equals x now. So it's passed through points with the x and the y value equal, like AA, 1, 1, 2, 2, minus 3, minus 3. Pass through points with the x and the y value is the same because y equals x on that line. So it's going to pass through those two points, 0, 0, and 3, 3. And that's important in this question of showing this point, Like the question is basically indicating that your line y equals x must pass through that point. And the function and its inverse must intersect at this point, 3, 3. Because if you have 3, 3 on the function, you switch them around, as I said, it's going to come back 3, 3 anyway. So a function and its inverse will always intersect the line y equals x at the same place, the same point. Right? So these 2 points, 0, 0 and 3, 3, the function and the inverse will pass through these 2 points as well as the line y equals x. Alright, so let me show the line y equals x now. So what you can do, guys, is listen back the video, listen to my explanation again, replay it and listen to everything that I've said. If you're not understanding clearly, go back and play the video, pause and play and listen to my explanation. Alright, so y equals x is the line that we want down here. That's like our mirror line. Alright, I can't draw it straight, so you have to bear with me. I'm actually trying to draw it straight. Y equals x. Alright, let's say that is it. Y equals x passing through here and through there. And that's a function we have right here. I'm going to draw the inverse in blue. So that I'm reflecting this black graph in this line. So you see this part of the function that goes under, reflection must go over by about the same distance, like that. And then now, this part of the function that goes above the line and seems to be going away from the line, see? The inverse is going to basically go under and kind of straightening out and going away from the line as well, because that's how reflection goes. So it's going to go like something like this. That blue graph is the reflection of the black graph. If you notice, for example, these 2 points, the end of here and the end of here, they are equidistant from that mirror line. Because that mirror line, that red line, is a reflecting line for the function inverse. That's what you're trying to accomplish. I want you to fully understand it. Alright, so this line here, I'm supposed to label up a graph. This line is y equals x. This is the function, and the inverse is in blue. So I'm going to label it f to the minus 1 of x. You must label up everything. And that is it. That's a graph of the function as inverse graphically. And the question went on to ask us this. What's the relationship? Right? It says state what the relationship is. So we have to draw the line that represents the relationship between them. That's the line y equals x that I've drawn in red. And then now we have to state the relationship. And the relationship is that what as shown on the graph. Function and inverse are reflections of each other. So the blue one reflect to get the black one, and the black one reflect to get the blue one in this mirror line, in this red mirror line y equals x. So they are reflections of each other in the line y equals x. What it is, is that f of x is the inverse of f to the minus 1, and f to the minus 1 is the inverse of f. They are inverses of each other, both of them. But just like because this was the original function given to us, f of x, then we call the inverse of f to the minus 1. But they are inverses of each other. In other words, if you take the inverse function and calculate the inverse in the same way, you're going to get back this function f. Alright? Understand that. So let's write out the relationship. This is that's f to the minus 1 of x and f, both of them, they are inverses. They are reflections of each other in the line y equals x. So anyone you reflect the line y equals x, you're getting by the other one. That is it. That is the class activity. Everybody good at that? Everybody okay? Everybody
Yes,
good?
sir.
Yes,
Yes, sir.
sir.
Alright, beautiful. Somebody have a question? No? Alright, let's jump to the papers that I sent in the group now. Alright, I don't remember the order that I sent them, but I think I have them in here. Alright, let me see. Let me just check it and capture the order. I think That's in 2021 first. Give me a second. Let me see. Let's see this. Right, 2021 first. Have it here somewhere. Love it. Alright. Alright. Which question did I say? I said 4. I think it's around question 4 on these papers. Question 4. All these questions we're gonna do, you know. All these questions I'm passing by now. We're gonna eventually do all of them. All of these questions gonna be done. As we do the topics, we will do them. That's what it is. Alright. Let's look at this one now on the screen. Come off a past paper from 2021. So this one gives us these two functions, f of x and g of x. This one is a simple linear function. This one is what we call a rational function. First part wants f of 9. F of 9 means we're going to put 9 in the f function right there. Nice and easy like that. Alright, so this is simply going to become equal to 1/3. This 9 goes here where the x is. And now we're adding 4. Now 1/3 of 9 is 3. Like the 9 divided by 3 is 3. So it becomes 3. And you're adding back this 4. So the result is 7. So f of 9 is 7. Then this part now is asking us for f of g of -3. Remember, this means you do the g of -3 first. I'm going to plug the g of the -3 in this function. See what it is, and then plug the result in the f function. Alright, so I'm going to put the -3 in there first. So it's going to become f of, I'm going to put the g of -3 in this bracket now. So put the -3 here on the numerator first. You're going to get 3 times -3 divided by, they're putting -3 here. You're going to get -3 plus 1. -3 plus 1. So this works out to be f of, what is this, as -9, and it becomes a -2. So it becomes f of, that's what now, 9/2, right? The negatives cancel, get 9/2. Now f of 9/2 now means that we'll put 9/2 in the f function right here. Alright? So it becomes 1/3 times 9/2. So this becomes 1/3 times 9/2. That's why I put the 9/2 right here. You get 1/3 9/2 plus 4. Plus 4. Alright? And then what does this work out to? This becomes 3 into this. It's already 3 into this 1 time, 3 into this goes 3 times. So this becomes 3/2. And then this turn that into a fraction over 2. What we can do is multiply it by a 2 and divide it back by a 2. So it becomes 8/2. So it becomes plus 8/2. 4 2 is 8, 8/2. 8/2 is still 4. Then we consolidate this, 3 and the 8 is 11. I see how come on the limit of 2 now? That's 11/2. That's the answer right there. Any questions on that? Everybody okay with that?
Sir.
Yes? You said yes?
Yes, sir.
Alright. This last part now says find the value of x if g of x is equal to 5/2. Now this can be done multiple ways. But what we're going to do is simply put this g of x function equal 5/2 and solve it. Tomorrow I'll show you another way to do it using inverse. Alright? So we're going to do it this. Put the g of x. The g of x is 3x over, what is it again? Over x plus 1. And that they say x plus 1, Mr. Shaw. And that they say is equal to 5 over 2. That's what we're solving. So if you have this equation to solve for x, determine the value of x. The g of x part is this. And now equal to 5 over 2. So it's an example where we can cross multiply. So what is it? We can take this denominator and multiply it up there by the 5. And take this 2 and multiply it up here by the 3x. Cross multiply to simplify it. Expand out everything into separate terms again. Alright? You don't want the x's dividing each other. So you cross multiply to expand out everything into separate terms. So let's go now. When you multiply this 2 up here by this 3x, it becomes 6x. Equal, multiply this x plus 1 times this 5. It becomes the x times the 5 is 5x. And then the 1 times the 5 is 5. Then now, you're going to bring this 5x away and subtract it. So you're going to get 6x minus 5x equals 5. Then 6x minus 5x is just x, 1x. X equals 5, and that is the answer right there. X equals 5. What about with that? Question done. But okay? You can check it now if you want to know. But I plug in the 5 back into the function now and see if you get 5 over 2. So we have g of x equals 3x over x plus 1. I would say what value of x make g of x 5 over 2? It is 5. So if we can calculate g of 5 and what happens and see what we get. So g of 5 will be equal to, I'll plug in the 5 in the g function now. It's going to be 3 times 5 right here. 3 times 5 divided by this 5 now. It's 5 plus 1. Alright? Now this works out to be 15, this works out to be 6. So it becomes 3 times 5 over this becomes 6. And you can see that 3 into this goes 1 time, 3 into this goes 2 times. So the final result, as you can see, is this 5 over 2. So it means that answer is right. G of 5 is actually 5 over 2 for true. See? So the x value inside here is 5. When the answer is 5 over 2. And that is it. Alright, are you okay with that? Can I move on?
Sure.
Alright. So next paper I gave you, like it's a short session we're having today, which is fine. The next paper I think I gave you 5 papers. Next paper I gave you was 2024. January 2024. So you see I'm giving you recent exam papers. Alright, so you see the temperature, standard of questioning that I setting. January 2024. Alright, again this will be about number 4 on the paper. Sometimes it's section 2, but I think it's around number 4. Right, here you go. Good. So I saw some solutions for this. Some process going alright, but they're making a few mistakes. And that's the beauty about doing the question before I do it. Because you learn from your mistakes. Making mistakes is good because you learn from them. Alright? Alright, so let's go. So this question says f of x is equal to this. And another function h of x is equal to 5 to the x. This is actually 5 to the power x. Alright? First part wants f of 4. F of 4 means you're going to put 4 in the f function right there. So this is simply going to become equal to 2 minus 5. And where this x is, we put in a 4 now. 5 times 4. 5 times 4 is 20. So that's 2 minus 20. 2 minus 20 is negative 18. That's the answer for that part, negative 18. Next part wants h of 0. Remember, h of x is 5 to the 0, you know. So h of 0 means that we'll put in 5 to the x, sorry. So h of 0 means that we'll put in 0 where the x is. So it becomes 5 to the 0. Now somebody did this and put 0 as the answer. No. Any number raised to the power 0 is 1. Any number raised to the power 0 is 1. Alright? And if you put this in the calculator, you're actually going to get 1 for it. Because some person put it and put 0. So you learn from mistakes. Any number at all raised to the power 0 is going to work out to be 1. Alright? So that is something that is good to know. Any number raised to the power 0 is 1. Alright, that is that. Let's continue. Then I want f of h of negative 2. Let's write them down, two functions again, so they're on the screen in front of us. So the f of x is 2 minus 5x, and then h of x is 5 to the x. Let's put them right here. So we're going to use a method where we recognize this as h of minus 2 first. So we plug in the minus 2 in the h function over here, so first, and then we apply the f on it. So this f of h of minus 2 is the same as f of, I'm going to put h of minus 2 on this function in the bracket. So it becomes 5 to the negative 2. You can write that out to the calculator if you want. We can recognize 5 to the negative 2 the same as f of 1 over 5 squared. That is what the negative 4 means. It means reciprocal. And then the 1 over 5 squared is f of 1 over 25. So we really want to find now f of 1 over 25. So put 1 over 25 right here where the x is now in the f function. So this becomes 2 minus 5 times. We put 1 over 25 here, we're going to get 1 over 25. Alright? And then now we're going to simplify this. 5 into this goes 1 time, 5 into this goes 5 times. So this result becomes 2 minus 1 over 5. That's what this becomes, 1 over 5. Now this now is the same as 10 over 5. To turn into a fraction over 5, you can multiply it by a 10 and divide it back. Multiply it by 10 and divide it back by 10. Right? No, not 10 over 1, this is 5 over 1. So multiply it by 5, sorry, and divide it back by 5. So it becomes 10 over 5. So this reduces to 10 over 5, that's what the 2 is, minus 1 over 5. 10 minus 1 is 9, so it's supposed to be 9 over 5. And that is the answer for that one. But okay with that?
Yes, sir.
That's a yes?
Yes, sir.
Alright. Let's move to the next part. Next part now was f to the minus 1 of x. Simple. The f of x, remember, was 2 minus 5x. That's f of x, right? Let me see. Yes. So again, to inverse this, what I'm going to do, I'm just going to leave off the f first. Alright, 2 minus 5x like that. I'm going to inverse it. And this f becomes x equals 2 minus 5. And this x becomes f to the minus 1. Then to make f to the minus 1 the subject, we can transpose everything away from it. We can carry over the 2 first and then take this negative 5 and divide it under. Simple. So we're going to get x, carry over the 2, get minus 2, then take this negative 5 and divide it under. Divided by that negative 5. That's f to the minus 1 left as a subject. Right? That is it. F to the minus 1 of x is now equal to this. Put down the answer in red. So I can write that f to the minus 1, that's this thing, is now equal to this thing. X minus 2 over negative 5. Okay, I'm putting back of x right here. Now, if you actually got this, if you do that, transpose another way, you could get these negative on this and negative on this. So negative on this, we switch those around and put as 2 minus x, and negative on this, we turn this into a 5. So if you get 2 minus x over 5, that's still correct. Or if you get that, that is it. Alright, then we'll come to this part down here now. It's a nice, interesting question. I want to show you something. This f of x, they could have given you this instead as f squared of x. Means the same thing as f of f. And f of f means f into itself. So so a number of persons doing it right, which is good. It means f into itself. And I want the answer to be like this when we're done. Now let's write the two functions and show how that would go. Use a different color. But remember that this f of f, they could have given to you as f squared, which means the same thing. So we get a question and it's f squared of x the asking you for. It means f of x. Remember that, guys, because they give it to you like this sometimes instead of f of f as they did here. Alright? Well, let's do it now. So I'm going to write the two functions. F of x is 2 minus 5x, and f of x is still 2 minus 5x. And so if we are now forming f of x, it means f into f. F into f. So it's like we're taking this one and bringing it and put it in the other one here where the x is. That person did it, as I could see in this and the solution that I saw coming in. So we're doing that construct. So like we're constructing that I've shown in red. So it becomes equal to this 2 minus 5, and then multiplying that now by all of f coming inside here. Again, which is 2 minus 5x. And now if you simplify it down to look like this, that's what I said. It becomes 2, and it's negative 5 times this 2 give me negative 10. Then negative 5 times negative 5x give me positive 25x. And then the 2 minus 10 is negative 8 plus 25x. And this is now in the form a plus bx. So this is now in the form a plus bx. A plus bx. So if you compare these, the a is negative 8 and the b is 2x. The plus b is plus, not 2x, 25. The plus b is 25. And that ends that question. But I write it that.
Yes,
Very
sir.
good. Alright. Alright, I have to make a quick call, guys. Give me a second. Somebody's calling my phone. Work related. Let's make this call quickly. A second. Find the next question in the meantime. Hello? What's up? Huh? Pick up the what? I think you called the wrong person. This is Rafik. Yes. Oh, you pick up? Yeah. The what? You pick up socks for me? It's not for me, you know. I think it's for Leighton, them, not for me. No, for who? For which company? For GFS? No man, it's not for me. Maybe it's for it's with GFS. For the thing tomorrow. I think it's GFS, man. I think they mixed it up. It's not mine. It's not mine. I think maybe it's GFS. You tell you which company? Most of Shah, man. Not Rafik Shah. Most of Shah. I didn't order anything from Western Sports. I didn't order anything from Western Sports. I ordered from somewhere else. No, somewhere else I ordered from this year. So it's not me. So ask him which Shah. Just ask him the first name. Who? Oh, well, if you can find the first name, or you bring it to the game tomorrow. Whosoever it's belong to must come to you, would come to you for it tomorrow. Yeah, alright, cool. Yeah. Yeah, it might be latent. Might be latent. Yeah, man. Alright, cool. Alright. Alright, students, sorry about that. That was work related. Sorry about that. Alright, we could just continue. The next question I gave you, that's two I've done so far. The next one was on 2023. Let's see, 2023. May 2023. Um, uh, 2023. Alright. Okay, this was the next paper I gave you. 2023. Was it number 4? Yep. Gave you this one. Gave you this one. So remember, guys, anything you got wrong, you need to go and redo it, right? Go and do it over. Get it right the right way. I gave you this one. Alright. This one says consider following function. That's a rational function. And say for what value of x is this function undefined? Alright, I didn't do this in the class. It's actually doing this tomorrow. Didn't realize that this was asking this, but the function is undefined when the denominator equals 0. Okay, you cannot divide by 0. Alright, so it's when x plus 2 becomes equal to 0. And that is when x equals negative 2. So negative 2 cannot be in the domain of this function of f. Because if x is negative 2 under here, you're going to be doing 3 divided by negative 2 plus 2, which will equal to 3 over 0. If you try to put 3 over 0 on the calculator, you're not going to get any answer. You're going to get an error message. Let me show you. So denominator of a rational function cannot be 0. Otherwise the function becomes unreal. Right? It's undefined. So you cannot have values of x in the domain that will cause the function, the denominator of a function, to be 0. So see, if I put 3 over 0 on the calculator, I'm going to get an error message. Where is the fraction button? Here. If I put 3 over 0, see, divided by is an error message. You get it. Cannot divide by 0. See, division by 0 not going to produce an answer. It's undefined. If you put on your calculator, you got some other kind of error message. Alright, so the function is undefined when the denominator is 0. So it's something we're actually going to be talking about tomorrow in class some more. But let's on top of that part. This one says now to find g of a quarter. So g of a quarter means you're going to put a quarter in this g function right here. This is the g function, putting a quarter in it. So this therefore becomes equal to 4 times a quarter and then minus 5. 4 times a quarter is 1 minus 5. 1 minus 5 is negative 4. Then the one h of negative 3. Easy. Means that I want to plug negative 3 in the h function right here where the x is. Let's write about what the h is. X squared plus 1. So the h function is x squared plus 1. So we're going to put the minus 1 there. Damn, the minus 3 there. So h of minus 3 is minus 3 squared plus back this one. The minus 3 squared becomes a positive 9. When you square a negative number, it becomes positive plus 1. 9 plus 1 is 10. So then that is 10. Anything else? Then we want f of 0. Same thing again. Now to the f of 0, can I find f of 0 first? What is f of x again? F of x is 3 over Is it 3 over x plus 2, right? 3 over x plus 2. So this is 3 over x plus 2. So I'm going to find this f of 0 first. So this thing, f of 0, remember it could have been f squared of 0, same thing. This and this is the same thing. This is f squared. So it means that we want to do f of 0 first in the bracket and put in a 0 here. So it becomes 3 over 0 plus 2, which is f of 3 over 2. And to find f of 3 over 2, we put in 3 over 2 right here now where x is, again in the f function. So it's going to become equal to 3 over 2 plus 2. To simplify this down quickly, that is 2 from under here, we can multiply the whole denominator by a 2 and also multiply this numerator by a 2 as well. So multiply this 2 by this, it becomes a 3. It becomes equal to this 2 times this 3 over 2, cancel 2, give me 3. This 2 times this 2 give me 4. This 2 up here now, times this 3 give me 6. So this reduces to 6 over, this becomes a 7. 6 over 7 is the answer right there. But okay with that? Very good?
Yes, sir.
Alright?
Yes, sir.
Alright, good. Next part. Wants us to form an expression for g of h of x. Alright, so what is the g again? The g is, I don't remember, I'm write them up here and copy them down. So the g is this one, 4x minus 5, and the h is this one. The h is x squared plus 1. Copy this down. And so forming g of h of x, which means h into g. So it means that you're taking all of the h, you're putting that in the g right here where x is. Simple as that. So that then becomes equal to, put back the 4 first. Where the x I can put in a bracket and put x squared plus 1. That's what the h is. And then subtract back this 5. And question highlight or bold up simplest form first. So you need to just simplify this a bit. Let me shift it up back so I can get some space. And you can see what I keep telling you about, guys. I don't give a lot of space for these things. Multiply this, expand this first, we get 4x squared plus 4. That's what this expands out into. Minus back this 5 out here. Then this stays 4x squared. And then this becomes minus 1. 4 minus 5 is negative 1. 4x squared minus 1. That's simple. It's never factorized, you know. So can we factorize that a little bit further? I don't know if factor form is simpler than this, but can we factorize? The difference of 2 squared, because this is same as 2x squared. 2x all squared minus this same as 1 squared. So then we factorize both sides. We factorize the difference of 2 squares. You're going to get 2x minus 1, 2x plus 1. We shift this over so we can write this larger. Not so clear. We shift this over a little bit. I'll shift this all up a bit. Right, so this then becomes bracket, 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 bracket. 2x, 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 Mr. Shaw. Minus 1 plus 1. I factorize it down to that. But I feel like if you stop right here, you get the marks. If you stop right here, in this question, I think you get the marks. Now it says yet another part. They want g to minus 1 of negative 2. and the g is this function. So to do this, again, the process is to find g to the minus 1 of x first, then we find g to the minus 1 of negative 2. Alright, so to do that, we're going to start by saying g equals, what is it? 4x minus 5 right here. I'm going to inverse it first, and the g is going to become x, and this x is going to become g to the minus 1 minus this 5. Make this is subject. What do we do? Carry over the 5 first, and becomes x plus 5. Then take this 4 and divide on the right and the left side over 4. That's g to the minus 1. But this is g to the minus 1 of x, and we can put in of x on it. We want of negative 2. So I'm going to plug the negative 2 in there. Right there and there. So we can say therefore g to the minus 1 of negative 2 means negative 2 going there. So it becomes negative 2 plus 5 over 4. So negative 2 plus 5 same as 5 minus 2. 5 minus 2 is 3 all over 4. That's the answer right there. But I write that. Very good.
Sir.
Remember, I'm doing these questions with the intention that you guys will go and redo all these questions if you got anything wrong, or if you did not do it. Alright? And you can always use the video to assist you if needed. That's what this session is about. For us to have continuous revision and for us to have practice. Remember, mathematics is a doing subject. You cannot just come to class and watch you do it. I feel like that is enough. That is never enough. Alright? That is never enough. Alright, let's see which one we're doing next. 2022, January 2022. I think we have 2 more questions and we can call it a day. I don't like when Saturday sessions too long. January 2022. Right here. Alright, so let's see which question this is. Is it number 4 again? So I said all these questions we're skipping over, we will eventually do all of them. We will eventually practice and do all of them. More than once actually. Alright, so this question is similar to one that we have done so far today. First part gives us these 3 functions. This is the f, this is the g, that is the h. Alright, first part wants f of half. You're going to put half in the f function right there. Nice and easy. That becomes 2 times half minus 1. 2 times half right here, so it's 1. So it becomes 1 minus 1. 1 minus 1 is 0. That's answer for the first part. Next part wants h of 0. Means I will plug in the 0 in the h function right here. Just do one like this. So any number raised to the power 0 is 1. So this h of 0 becomes 5 to the 0. And 5 to the 0 is 1. Simple as that. Nice and easy. Next part 1. There's a square now. There's a square. See there? This square. This actually now means g of minus 3. You mean that you're going to square the function. What is the g function? The g of x function, let's write it down, is what? The g of x function is 3x plus 2. 3x plus 2. Right here. 3x plus 2. That's what we're doing. See the small amount of space you get to work with, guys? So I keep telling you. Till in class, you see it for yourself, you know, you don't get a lot of space to work with. Sometimes you have to divide the space and work half of it here and half of it there. Alright? So we're going to do the g of minus 3 first. So it becomes g of I'll put in g of minus 3 inside there now, which is to put minus 3 in the g function. So it's 3 times minus 3 plus this 2. Or 3 times minus 3 is negative 9. Negative 9 plus 2 become negative 7. So we're now doing g of negative 7. On g of negative 7, you're going to put negative 7 back in the g function there. So it's now going to become equal to 3 times negative 7. That's why I put negative 7 there. Plus this 2. So 3 times negative 7 is negative 21. Plus back this 2. Negative 21 plus 2 become negative 19. That's the answer. Negative 19. Are you okay with that?
Yes, sir.
Alright. Now here I want the composite function g of f. What is the f again? Let me write it here. So f of x was what again? G of f. 2x minus 1. So this is 2x minus 1. Let me just copy these down. And slide them down. This small amount of space you get to do. It's composite function. And you have to simplify as well. Alright, so you see I keep telling you a small amount of space you get to work with in an exam. So you have to be very efficient with your working. So this one, g of f. Remember, g of f means f into the g. Means that we're taking all of this f right here, bring it and put it into the g wherever the x is right here. That's how we form the composite function. So the g of f of x will result from that red on that construct in red. So we're going to put by the 3 where the x is, we're going to put the 2x minus 1 and you add back this 2 out of the end. And it's the simplest, so if we simplify this, 3 times 2x is 6x. 3 times negative 1 is negative 3 plus this 2. Right? Then negative 3 plus 2 is negative 1, so it reduces to 6x minus 1. That's the answer right there. But alright with that, check in.
Yes, sir.
Alright. So nobody don't answer, I'm assuming that you're okay now, guys. I'm assuming that you're okay. If you don't answer, I ask a question, you don't answer, I'm assuming that means that you're good. Let's continue. Next part I want is g to the minus 1. So you have to throw everything at this question. The g is 3x plus 2. So the g of x is 3x plus 2. Alright? So I'm going to follow the process again. We're going to call it g first equals 3x plus 2. Some teachers call it y, I call it by the same letter that was given. I want to inverse it. When we inverse it, the g right here, which represents range, becomes domain x on the inverse function. This x represents domain on the function, becomes range on the inverse function of g. So put by the 3 and then the x becomes g to the minus 1. Range on the inverse function, you put the minus 1 on it. Plus back this 2. Then to make this is subject, take this 2 and bring it over first. You get minus 2. So you get x minus 2 first. Then this 3 is multiplying the g, divide it on this side. Divide the 3. That is g to the minus 1. And then we can write the conclusion. Let's put it in a different color. Put it in a different color. Put it in red. And so therefore, g to the minus 1, that's just g to the minus 1, is equal to this thing. X minus 2 over 3. That's actually g to the minus 1 of x. So I'm going to put in of x on it. And that is the answer right there in red. Very good so far.
Yes, sir.
Nice. Anything else? Wow, still something else. This question says, hence or otherwise, determine the value of x when g to the minus 1 is equal to 4. I'm going to do this 2 ways for you and show you something, even though I don't do this yet. So since we work out g to minus 1 of x and it is equal to this, they want to know what it is when it is equal to 4. So I can put this expression as my g to the minus 1 of x and put it equal to 4 and solve it. Alright, so let's do that way first. So I'm going to put the x minus 2 over 3 as my g to the minus 1 of x, put it equal to 4. Right, and then solve for x. Or solve for x. Take this 3 first and multiply it up here. I'm going to get the x minus 2 equals 12. Then take this negative 2, carry it over here and add it. So we're going to get x equals 12 plus 2, which therefore is 14. So the answer for this is 14 as the answer. But the other way to do it, they say hence or otherwise. No, the hence basically means that we must use this result, you know. The otherwise means that we can do it any other way. So I'm going to show you another way that we could do it in blue. So this is the hence method that we just did over here. This is the hence method that we just used. And the hence method means that we use this result in the process. If we do it over here using an otherwise method, some other method, we could say, okay, watch this now, guys. G to the minus 1 of x equals 4. What that mean? It means that the x right here is equal to the g of 4 now. I could transpose the g and put it on the 4. And so the x is g of 4. That's something we're going to deal with tomorrow's class. I just showing you something now. If g to the minus 1 of x is equal to 4, it's almost like you take the g then and put it on the 4. The inverse of the g is g. The inverse of g to minus 1 is g. So to work out the x's, what the x is, we could work out g of 4. We work out g of 4 now, we get the same 14 here, so let's prove it. G of 4. What is g again? The g function is 3x plus 2, right? 3x plus 2. So if you want g of 4, you put in 4 inside here, so you get 3 times 4 plus 2. 3 4 is 12, 12 and 2 is 14. So you're getting the same thing. If g to the minus 1 of x is equal to 4, then the x equals g of 4. And the g of 4 in this case came out to 14. Same answer we got over there. Doing it that way. So that's 2 ways I show you. Watch about the video, listen to what I've said. Right? As we get better and better in the functions, I show you some other stuff that it's good to know. The more things you know, the better. Alright, because we're doing a question, I want to do it the easiest way possible. Alright, so that is it, and that finishes that question. So a question like this, I want to look back at what Mr. Shah did. Look at it one more time and learn from it. But it is right here, see guys, what is it right? It's the function as inverse we use, you know. It's like what this is, right? It's like say, okay, the x is mapped onto the 4 using the g, so that you have an x and map it onto 4 and using the g function to do it. The g of x, the g to the minus 1 and g to the minus 1 to do it. So it means then that this 4 is mapped onto the x using the g. That's what it is, you know. So if you apply the g to the 4, you're going to get the result of x. That's what we have on this line. Right? So that's what it is. So if g to the minus 1 take it from x to 4, then the g, which is the inverse of g to the minus 1, I'm going to take it from 4 back to g. Because a reversal of the mapping. So anything g to the minus 1 map one way, g to the minus 1, if g to the minus 1 has a mapping one way, then g has the mapping the opposite direction. Because g to the minus 1 and g are inverses of each other. They reverse the mapping. So remember that. They reverse the mapping. Alright, so that's how it works. But okay with that? Alright.
Yes, sir.
Let's continue. So, I did the wrong thing. The next question, next paper I gave you. What was it now? Let me see. This paper I gave you was 2015, so far down. 2015, and it's June 2015 paper I gave you. I think this is it. Alright. What question is it? This is the number 4 again. Notice so far guys it has been number 4, but sometimes you can get functions in section 2 too, and it's possible. Alright. But most times it is in section 1. So it's not this one. So I guess this one is what section 2 then. Let's see. If not in section 1, then it can be in section 2. There you go. See that? So it can come in section 1 and come in section 2. Looks like in more recent times it's coming in section 1. Because 2015 is our old syllabus. Alright, this question gives us these two functions, f and g. First part wants g of 5. Let me zoom it up. So g of 5 means you can't put the 5 in this, no, it's the g one you're putting it in. So you put the g right here, the 5 right there in the g function. So this simply becomes equal to 5 squared. When I put the x right, the 5 put the 5 with the x's, I get that, minus 1 over 3. So 5 squared is 25. 25 minus 1 is 24. This reduces 24 over 3. 24 divided by 3 is 8. So the answer for this is 8. Are you okay with that?
Yes, sir.
Alright, nice. Then I want f to the minus 1 of x. Alright, so same thing again. This is the function, I'm going to inverse it. So let's start by saying f equals 3x plus 2. That's it, right? Yes, 3x plus 2. And we're going to, you see, we don't have a lot of space. So we'll be very efficient with the work. So we're going to inverse this now. We inverse it. The f, which is range, becomes domain on the inverse. 3 times this x is domain, now it becomes range on the inverse. Range on the inverse of f is when the f to the minus 1 plus 2. Then we need to make this subject now to get the inverse function. So take over the 2 first, it becomes x minus 2. And take this here as is multiplying and divide it under here. Divided by 3. And that is f to the minus 1. And now that we're done, we can write it. We can say therefore f to the minus 1, that's this f to the minus 1, is equal to this thing, x minus 2 over 3. We can put the of x here. That is it. Very good?
Yes, sir.
Alright, next part now wants g of f. Right
Yes,
now.
sir. Yes, sir.
Alright, good. Next part wants g of f. Let's set it up. So the f function is 3x plus 2, and the g function is x squared minus 1 over 3. Let me copy them down. Put them right here. And the question asking us for this thing, which means f into the g. Alright, so we're taking all of the f. I'm going to bring it and put it into the g, where the x is right here. That's how we're going to form a composite function. So it is g of f of x, which I just said means f into g. So that result becomes equal to, when I put f into the g, where the x is, I'm going to have the entire f there right away. So I'm going to have 3x plus 2 all squared minus back this 1 divided by this 3. But I want to answer in this form. says that we're going to expand out and factorize. Let's expand this out and be careful now. Still not a lot of space to work with. Right? Still not a lot of space to work with. So this becomes equal to. Remember, when you expand a perfect square, you must get 3 terms, guys. So remember that. So you get the first term squared. When you square 3x, you're going to get 9x squared. Then you get twice the product of the two things. Or you do twice the product of the two. Multiply these two things first and then double the result. When I multiply them, I'm going to get 6x. Double 6x, I'm going to get 12x in the middle. Then this second term squared is 4. And you have to subtract this 1 out here. All over is 3. So this then becomes equal to, this is 9x squared. This is plus 12x. And this is plus 3. That's all being divided by this 3. This one and here. You can divide each term by 3, so you can simplify. Divide this by this 3 first, you get 9x squared. No, you get 3x squared, sorry. Divide this by 3, you're going to get 4. Divide this by 3, you're going to get 1. Then you see I'm factorized. Factorize 3x squared, you get 3x and x. Factorize 1, you can only get 1 and 1. Signs are the same, they are both positive. Plus. That is it. That is it. When factorize this, that's what we're gonna get. We have gotten in this factor form right here. That's it. Alright. That is it for today. Quick and fast, nice and easy session. Got a lot of work done. A very short session. And all you need to do now, guys, about an hour and a half, very good. That's all I like to do on a Saturday. You can fast, at least, you don't get too tired, too bored and stuff, and lose interest. All you need to do now, guys, is go and redo the questions. If you get part of a question wrong, you go and you work it over. If you did not do the questions, you're going to do it. It's very important. Don't waste these sessions. Put them to use. Learn from your mistakes. It's very important that you do the questions before I do them on a Saturday. So
Excuse me, sir.
Learn from them. Yes?
Could I find this on YouTube?
Yeah, I'm going to send the link to the group. What's the matter with you? Every week. That's
Oh,
what
sorry.
I do.
I was just asking my question.
Means that you've not been watching the videos. That's what it tells me. Means that you've not been watching the videos. Alright, so let it not be the case going forward, please. I'm going to send the video in the group, the link right in the group. Yes, it's live. I record it on my channel on YouTube. That's why I have my channel on YouTube. And you go there and send the link and you watch the video. And you redo the questions as you go. Redo the questions. Use the video as an assistance to help you. Use it as revision and practice. Come on, take full advantage of everything that is being offered in this program. Alright? So I'm going to send the video right after the class. Any question you get wrong, redo it. And the video is there to help if you need it. Alright, and for those who are not here, hopefully they will use the video as well in that sense. To watch the video because they are not here. But that is it for today, guys. That is it for today. You can fast, nice and easy. Alright, see you in class tomorrow and Monday. We're going to do some additional functions work. What we have done so far are the normal functions questions. Focusing tomorrow on the functions questions that are not set often. The ones that you need to remember. There's functions questions that don't set very often. Such that if you set one of those on our exam paper, you are still able to do it. Alright, so that's the focus for this week. Functions question that they don't set very often. We're also doing variations, right? We're also doing variations. So it's two things we're doing. Functions question that they don't set often, and also doing variations. That's another topic that we must know that comes under the banner of functions. Alright guys, enough talking. See you tomorrow. Bye everybody. Have a good day.